Okay. Introduction to the unit circle and Caste Quadrants. First thing to do is to work out quadrants. So think of a Cartesian plane. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Yes, they're numbered, there's 4 of them, and that's the order that they go in. Unit circle, so we're going to be thinking about angles going around in a circle. A unit circle, lots of textbooks will talk about all these radiuses being equal to 1, so it's a unit circle. Lots of times, I'm not going to be talking about a unit circle. It would just be, I'm going to have a radius of 2, but that's okay. Hopefully by now we're also used to the fact that I'm going to say that if that's 30 degrees, I'm going to call this a terminal ray. Okay, so if I say that my terminal ray has a length of 2, I'm going to draw a blue line there. And how long is my red line? Hopefully you recognise that it's 1. And my blue line is root 3. Then we're going to say, think of this as a point on a Cartesian plane where it's x, y. Hopefully you're happy that that's root 3, 1. So for the terminal ray, for the angle of 30, my x component is root 3. My y component is 1. More importantly, we don't really care about the number, we care about whether they're positive or negative, and both of them are positive. If you're looking at a textbook and it was a unit circle that was drawn, all they're going to do is have the exact same diagram, but because that's length 1, then that's going to be, everything's going to be half as big. So this point P will be the point root 3 on 2 and a half. It's irrelevant what this number is. We're really looking at whether it's positive or negative. So for me, let's just keep things easy and just use a radius of 2 so that these numbers are easy to think of. Okay, good-o. Let's think about a different angle. Let's think about an angle of 120. Let's go with the same thing. I've got a blue line and a red line. Hopefully you recognise that in there is the angle 60. So that's going to be my root 3. And that's going to be my 1. And if I had this as a point, it's going to be the point -1 root 3. So again, it doesn't really matter that that's 1. What really matters is that you can recognise that the x component of 120 degrees from your terminal ray is negative. The y component of 120 degrees is, well, y is positive up there, isn't it? So that's positive. That's really all we need to in this video is work out what the components are and whether they're positive or negative. The other thing you'll see is the Caste Quadrants. We're going to be using this positive and negative components to work out whether our answers are negative or positive. You'll also hear or see textbooks or teachers talking about the Caste Quadrants. Oops, my desk didn't come out. Caste Quadrants. Caste, yeah, or the acronym is All Stations to Central. I'm not really into gimmicks, but what this A stands for is all trigonometric ratios in that quadrant are positive. So sine, cos and tan are all positive. Over in quadrant 2, sine is positive and everything else is negative. Down here in quadrant 3, tan is positive and everything else is negative. And in the C quadrant, quadrant 4, cos is positive and everything else is negative. So yes, you can use your Caste quadrants to work out whether your answers are positive and negative. Look at my next video. But there has no justification or reasoning or understanding if you're going to use Caste, whereas your concept of these components is how trig works, and I really want you to understand it, not just remember it. Okay, watch the next video because that goes into some examples.